Hi everyone, today our topic about tangents and secants to a circle exercise 9.2 fifth problem. To understand better this construction of tangents to a circle, first I will show you how to draw a tangents to a circle. With the given radius, first you locate a dot, then draw a circle using compass like this. Okay, from the distance external point to the center, if you know or if you don't know, simply you draw a ray like this. Now if there is a point P to draw a tangent, then how can you draw means, first take more than half of the distance for this line segment center to this P. This is the more than half of the line segment, this radius. Draw an arc above the line segment with the help of point P. Draw another arc below this line segment. Now again draw an arc at point O to intersect previous arc in the same way below also. Now draw a perpendicular line segment through these two intersection of arcs exactly. Then we know the exact midpoint of this distance. Now with the help of this exact midpoint, we can know where this tangent can intersect to the given circle. For that we can simply draw two arcs enough, otherwise we can draw a circle. This circle, why? Because to understand where a tangent intersect to a given circle, for that sake. Otherwise simply two arcs are enough. Now draw tangent from point P to a circle, another tangent from point P where that circle is intersect there. Understood how to draw tangents to a circle? Okay. Now fifth one, draw a circle of radius 6 centimeter. Just roughly I draw a diagram to understand the problem. With the radius 6 centimeter, draw a circle from a point 10 centimeter away from its center. The external point to center distance is 10 centimeter. Construct the pair of tangents to the circle and measure their lengths. So asked to construct the pair of tangents. How we can construct means, see, step by step I explain you. Locate the center at O with the help of compass. Take radius 6 centimeter. How means, with the help of ruler, take radius 6 centimeter like this. Now draw a circle. Understood? Like this you draw a circle. Then from point center O to draw a ray. After that you locate the distance from center to 10 centimeter away at point P. Then P to O distance is 10 centimeter. Now you draw a perpendicular bisector for this 10 centimeter. How means, take more than half distance. This is 10 centimeter. Half distance means 5 centimeter. More than 5 centimeter. Above one arc, below one arc. Now from this point O to intersect this arc, then below intersect the intersection of this pair of arcs and this pair of arcs, you draw a perpendicular line. Why needed here to draw a perpendicular bisector means to know the exact midpoint of this line segment. Otherwise 10 centimeter exact midpoint is 5 centimeter. You look at a point 5 centimeter, then you can draw, see, you can draw this 5 centimeter, take as a radius, you draw a circle like this, Otherwise simply you draw an arc here, an arc here. Why these two arcs means where tangent line intersect to a circle for that point. Okay, now from the point P to B a tangent, from the point P to A another tangent. So finally we draw two tangents to a given circle. Now construction. How you construct the diagram? Write few steps. I drawn a circle with the radius 8 centimeter. OA is equal to 6 centimeter. What? Draw a circle with radius OA equal to 6 centimeter. With the radius 6 centimeter, I drawn a circle. Like few points you write how you constructed this diagram and verify by using Pythagoras theorem. One more question. In this diagram, OAP, this is half side, a right angle triangle, at point A right angle, OAP. In the same way OBP are two right angle triangles. In a right angle triangle, hypotenuse square is equal to side square plus side square. We know the value of 6 centimeter. Another one is 10 centimeter. Hypotenuse 10 centimeter. Perpendicular side is 6 centimeter. Then base side is equal to 10 square, 100 minus 6 6 are 36. 64 will come. Then square root of 64 is equal to 8 centimeter. The length of tangent is 8 centimeter. If one tangent length is 8 centimeter, then automatically another tangent length also 8 centimeter. I hope you understood the fifth problem. Now next, sixth one. Construct a tangent to a circle. Construct a tangent to a circle of radius 4 centimeter. First draw with the help of radius 4 centimeter. First you draw a circle from a exact point on the concentric circle of radius 6 centimeter. One more circle with the same radius with the same center point. One more circle you draw with the radius 6 centimeter. Measure its length. Also verify the measurement by actual calculation. See, two circles needed to draw here. One circle radius 4 centimeter. Another circle radius 6 centimeter. Now needed here to draw a tangent to touch big circle to small circle. For big circle this is a secant, and for a small circle this is a same line tangent. Okay, but question is where we can know, how we can know the exact touches the point of tangent. For that sake, check this distance AO. Otherwise, take the distance AO more than half. Draw an arc with the help of point A. Above this line segment, you draw an arc like this. See, take this is half, more than half. You draw an arc above the line segment, below the line segment. In the same way, from the center you draw an arc to intersect previous arc above the line segment, below the line segment. Again you draw a perpendicular bisector through these two intersection of arcs. Then we can know the exact midpoint of this line segment. Now take this distance as a radius. Which distance? Half the distance of this line segment. Why this distance means where this tangent touches the small circle for that sake. Understood? Now we know the point P. From point P to O you draw a line segment. Then finally you got APO, right angle triangle, because tangent and radius relation is right angle triangle. Now question is, what is the length of A and P? Using Pythagoras theorem, AO square is equal to AP square plus PO square. Okay, AP square is equal to, this AP square is equal to AO square minus PO square or OP square. 6 square minus 4 square is equal to 36 minus 16. Their difference is 20. For 20 there is not have exact square root. So write as factors 4 and 5. 4 5s are 20. Square root of 4 is 2. Then remaining root 5 centimeter. The value of root 5 approximately 2.236. Then the distance between A to P, 2 into 2.236, approximately 4.472 centimeter. So approximately their distance is 4.5 centimeter. Okay, now seventh one. Before problem I explained you how to draw tangents to a circle. That is main important in this exercise. Draw a circle, know what is the exact center point. With that center point you draw a ray. If you know the distance between external point to the external point to the center point, then you locate that external point. Otherwise somewhere you locate the external point on this ray. Now the distance between A to center O, take more than half of the distance, draw an arc above the line segment, below the line segment from point A. Again you draw an arc above the line segment to intersect previous arc like this, to intersect previous arc like this. With these two intersection of arcs you draw a perpendicular bisector. This exact midpoint to center take as radius. This take as radius. Draw a circle, otherwise draw a small two arcs. These arcs helps us where these tangents touches to the circle. That exact point we can know. Understood? Then easily we can draw AQ, AP, then Q to O, O to P. Now question, draw a circle with the help of a bangle. Take a point outside the circle, one point outside the circle. Construct the pair of tangents. Simply take the scale and you construct the two tangents. From this point to the circle, measure them, write conclusion. In the question asked us, draw a circle with the help of bangle. Wait. Simply with the help of bangle you draw a circle, one external point, draw two tangents and measure them and write the conclusion. Means what is the distance from point P to A and point P to B, like question asked here. Okay. AP and AQ are two tangent segments from outside a point A to the circle. Construction. How you constructed this diagram? Write few steps. In two triangles OPA, above this line one triangle, OQA, below this line segment one triangle. In these two triangles radius is same, so one side is same. For these two triangles common side is OA, so another side also same. And at point Q, at point P, 90 degrees, 90 degrees, right angle. So one angle also same. By the using of right angle hypotenuse side criterion, these two triangles are similar to each other. So AP is equal to AQ. Conclusion: the length of the two tangents drawn from an external point to a circle are equal. This is the theorem in AP State Mathematics textbook, maybe in theorem 9.2. Okay. Now next, eighth problem. In a right angle triangle ABC, a circle with side AB, a circle with side AB as diameter is drawn to intersect the hypotenuse AC in P. Prove that the tangent to the circle at P bisects the side BC. Here main question is we needed to prove this PQ or this point Q bisect the side BC. Bisect means BQ is equal to QC. This diagram given in the question itself. Using this diagram we can conclude some conditions. Among them, ABC is a right angle triangle given in the question. Angle B is 90 degrees also given in the question. We know the theorem in a tangents and secants to a circle. The theorem is the length of tangents drawn from an external point to circle are equal. See, in this diagram, Q, one external point, Q to P, Q to B, these two are tangents. Q to P and C to P is not a tangent. Okay, Q to P, Q to B are the tangents. So using this theorem, QP is equal to BQ. What required to prove BQ is equal to QC? That one, okay. Now using this theorem, QB is equal to QP. Assume this is first equation. Now if you observe this diagram, here drawn two lines, here also drawn two lines. This means that in this triangle, these two angles are equal. In any triangle, if two angles are equal, then we know that that triangle is isosceles triangle. The property of isosceles triangles, equal angles opposite sides also equal. Now angle C opposite side PQ, angle P opposite side QC. So PQ, QC are equal using isosceles triangle property. QP and QC are equal because angle C opposite angle PQ, angle P opposite angle QC. Using these two lines we can confirm that this side equal to this side, and using the external point to a circle tangents QB equal to QP. Got it? So this is the second equation from 1 and 2. In 1 QB is equal to QP, from 2 QP is equal to QC. Right, first QB is equal to QP. Now QP value is QC. So finally QB is equal to QC. So PQ bisects the BC. Hence we proved. 8th one also completed. Now 9th one. Draw a tangent to given circle with center O. A a point R outside the circle, how many tangents can be drawn to the circle from the point? The distance of 2 points to the point of contact is the same. Okay, draw a circle with some radius. Now locate the midpoint O. From that midpoint to you draw a ray. On a ray, somewhere you locate point R. Now the distance between R to O, take this distance and draw an arc more than the half of the distance above this line segment, one ray from R, below one ray from R. Again, from O, you draw an arc more than this half of the length, one arc above, one arc below. The intersection of these two arcs the intersection of these two arcs, you draw a perpendicular bisector. With the help of this perpendicular bisector, you take the distance from O, center O to midpoint, center R to midpoint, same will come. So now with the help of this midpoint, you draw an arc here, you draw another arc there. This arc use is where tangent can touches the circle, we can know the exact point. Then finally you draw a line from R to this circle and arc intersecting point. From R to circle and this arc intersecting point. Then these two tangents we will get. How many tangents we can draw with one external point to a circle means we can draw only two tangents using an external point to circle. Thank you so much. I hope you understood. And watch my full video, subscribe my channel and share to your friends. Thank you so much.